How's it going, everyone? Elier Gonzalez here. Right now, we got an issue with, or I got an issue with the light bulb at my room, but I hope I can fix that in the next couple videos. But well, right now, here we're going to look at this asynchronous nature in JavaScript, specifically at how the EX6 and EX7 features from the language now allow us is to use these features like promise, what promise is, what is the mechanism of promise, as well as the async and await, and what are the particularly patterns or mechanism that it's using as a way to now allow us to write a code that look like natural for JavaScript, that look like the way how JavaScript actually evaluate the code. This scripting language, this is an interpreted language, line after the another. So that's the goal of this course, which is a course taught by Will Sentence. So shout out to Will Sentence, the CEO of Codesmith, which is a software residency, machine learning, a software engineering and machine learning residency that wants to bring all of the people that come from different backgrounds in the boot camps or that had different experience in not only boot camps but also on the industry, and now kind of accelerate into senior roles. In other words, accelerate that into places where they can provide much more value, where the industry actually needs them. So there's a couple of things, especially to describe as a way to recap those skill sets that you as an individual are going to provide not only for your college, the companies, but also to yourself. And that is the analytical skills. How is your thinking process, your technical communications? Can I implement your solution based on your explanations? And then look at the good engineering practice, as well as the soft skills, such as, have patience, be empathetic with others, as well as the domain language specific, which is the last things that something that almost all of us can learn. But all of these prior layers are actually quite hard, especially as you move on down in your career and you try to make sense of all of this different concepts and abstractions that especially for JavaScript developers have to deal with. And because of that, we're going to take a look now at this quick overview of the intro, the async nature, the promise, and iterators, and now finally getting into what is generator. So introduction here as a way to now remember that at the end of the day, the JavaScript fundamentals, which is the thread of execution, it evaluates line after it evaluates a statement or a line after the another. That's exactly what it's doing, the thread of execution. Then you have is the variable environment where it can be global or per functions. When you run a function, when you create a function execution context, okay? And then now how you can is keep track at which line of code you are, especially when you have nested functions called in, right? So the call stack allows us to do that. And ultimately is this nice little bonus features that comes with JavaScript, that is closures, that allows us to access to the outer scope from inner scope. You can think of this like a backpack of variables and methods that now this inner function can have access to. Okay, and this little backpack is a way to say, oh, when I look up at my backpack, hey, I have this particular function that comes from outer scope this function and these variables and other variables and that kind of thing, you know. So this analogy of the backpack is something that is quite interesting and can help you to understand when you are writing your code. And then we look at the async nature in JavaScript. How can we handle this? And how, because at the end of the day, JavaScript is a language that doesn't deal with any async nature. And that's why we have, for example, facade functions that allow us to defer tasks that will take sometimes in the future to be completed or to complete, such as set timeout, which is something that is on the browser as well as on the node, and how this is something that you can have access from node environment or for the browser, and you can pass functions that will be after a couple milliseconds, after a period of time that you can specify. You will get that and evaluate, and then JavaScript will evaluate. That process you will get that is now known as the callback queue, which is the way of how now the host, the browser, or the environment or node is now adding all of this. Is a way of how now the host say, hey, I got all of these pending callbacks, all of these pending functions for you, JavaScript, to be evaluated. And the person that is responsible to actually notify JavaScript about this, or the mechanism, is the event loop. So the event loop now, it say, okay, let me now first see the call stack of the JavaScript world. If it is empty, let me then take a look now at the callback queue, right? Grab one, pass to the callback, to the call stack. JavaScript detect that and say, hey, I got something in the call stack. Let me evaluate this function. Once that is done, I'm going to remove from the call stack. Hey, I got another function in my call stack. Let me evaluate that line by line, and then remove that. And this process is so mechanical and fast that you now have this wonderful thing of how you can defer async tasks or tasks that will complete sometimes in the future. And once you know, one of the benefits of this is that once you know this, it's quite fairly simple to reason about it. Okay. One of the trade-offs is because it becomes lengthy and verbose. This is something that you have now, is the callback hill or the pyramid of doom. It's not readable. So the ECMAScript designers say, hey, let's go now to give it a go with this thing, feature called promise, as a way to say, well, we would like to now make our life much more easier when it comes to read asynchronous operations that look like somewhat similar as reading line of code, right? In a normal execution or in a normal thread of execution, right? So now we have this promise object that it will create on the JavaScript world is the value as well as the state, where now in this pending state you can have values like initially will be pending. So this is a task that will be due. It will be the initial value of this will be a task that we don't know what it is, but is pending. Okay, and when that operation is done, whether it's successful or rejected, you're gonna update that state. You're gonna get the value, whether it's a success or a rejected. Okay, and then you now have the ability to attach is a callback when something goes wrong or right. which is on fulfill or on rejected, which is on .then or on catch. And not only that, we will have is the ability to actually, when something went well, pass down to the next promise, or in other words, pass down to the next async operation. So with promise, we have much more fine control about what's going on. So not only that, is that we can now have much more control when you define it as set timeout, which is a great thing. But the other is that when tasks that you don't have control, for example, network operations, read files, or file system operations. So the idea here is to say, all right, now that this makes a lot of sense, okay, especially when it comes to handle these async operations, the way how promise now works, especially when once this call or once this function or once this asynchronous task is being completed or not, okay, the mechanism involved that is, if you're using, for example, the fetch web API or the file system web API in Node, the thing here is that if there any error or success, it'll be attached now to this micro task queue, which is now the host that again is adding all of this micro task when you're using a promise, or when an operation usually, or when an operation returns a promise. In other words, when there is an async operation, but usually when an operations return a promise, which is most of the time file system operations in the context of Node, or fetch operations in the context of the browser, as well as Node. So with that, there's some side notes to know, because once we know that this is the micro task queue, that would allow us is to actually now evaluate all of these asynchronous tasks, okay, whether it's successful or not, okay, and pass down to the JavaScript world, to the call stack as a way to be evaluated. But the event loop now has to change its behaviors a little bit. And this is part of the MDN docs when they describe the behavior that now the event loop actually does right now. And that is, first is going to evaluate is all of the tasks inside of the micro task queue until exhaustion. In other words, it's going to grab all of these different callbacks, whether it's successful or rejected, I don't know, but this is what is going to now have the ability to pass down to the call stack. So the point of this is that once that micro task is empty, then the event loop is going to evaluate the callback queue, grab the oldest one, which is, since this is a queue, first in, first out, okay. Now it's going to pass that to the call stack to be evaluated by JavaScript. When that is done, then the event loop repeat the process. Take a look at the micro task queue. Grab all of the callback until exhaustion, and then evaluate the callback to get the first new element here, pass to the call stack, and do that again. So this particular process is something that you have to be careful, especially if you want to add a lot of micro tasks here, because this is one of the things when you're working with the micro task queue, for example, with promise or for service worker. It's like you can add as many micro tasks you want, including when you are now adding micro tasks to the micro task queue. Okay, so you can end up having now is an endless. You can end up having an endless. You can end up having an endless micro task evaluations. So it will never look at the callback queue. So when we look now, quick note, when we look now at Node, where it has several phases, several rules, several callback queue to evaluate in the context of the server, such as timers. This is when you evaluate all of your timers. Then you look at the pending callbacks. This is usually when you evaluate is TCP error connections, which is part of the 4th layer of the OC model. The OC model is the way of how now different computers, okay, can talk each other. So for example, how a mainframe, how a iPhone, Android, Mac, Windows, Linux can communicate each other, and even with different hardware requirements or hardware specifications. Some of them can have 32 gigabytes and some others like 4 gigabytes. It's like, what in the F is, well, why are you using something with 4 gigabytes? Perhaps you are running some Arduino for the Internet of Things. So now the point of this is like, that's something interesting, beautiful, because once you are able to look at and describe what happened here, especially here on these different phases, the timers, and then the pending callbacks, and then the idle and prepare, where now the next phase is the poll, where this is now the data connection happens, and the data connections happens, and then you have now is the poll, the poll, the close callback. The poll and the close callback. So I have the timers. The timers, the pending callbacks, the idle and prepare, the poll, the close callback, and there was something there. The close callback. The close callback, the event loop, the poll, the check, what the check phase is doing. Oh, it's when it's evaluating is a set immediate, which is another timer here. Okay. The check or the phase where it evaluates the set immediate, and ultimately the close callbacks. So for example, like socket that destroys, or the close event. Okay, so the check, the set immediate. All right. So now that we know this, okay, in order to understand how now the async and works, just to recap that, look at now the callbacks, the promise, the micro task queue, the web APIs, and the event loops. All of these features allows us is to now able to defer tasks until that is completed, while we're doing in the background, in the background evaluating is all of these different statements without blocking the main thread. Okay, and now we can allow this functionality that is something in demand and something that you're going to see a lot. Now you can allow is this modern web JavaScript applications capable of handling async operations. You know, that we're talking to a server, reading a file, and that kind of thing. So that's beautiful, because now you can take a look at your own now you can take a look at your own, how do you put it, now you can take a look at your own now you can take a look at your own balance account quickly, almost in real time, or in real time. You can also look at now the so what's happening is on the market, okay, and that kind of thing. So that's something beautiful. That's lovely, truly lovely to look. So before now look at this new syntax called the async and await as a way to understand that now how by writing is the async and await in our code, we can guarantee that in the next line we are going to have now the data available, which means that we're going to write code that actually looks like the JavaScript code. In other words, it analyzes one statement after the another. So okay, no problem. So before diving into this, I look at a particular thing called iterators. So iterators is just a way for us access data. What does it mean? Because usually when we create an object, we are defining is a particular state. This is what is known in React applications, that kind of thing, is the state of the application. So you have now this particular object. But usually we don't deal with just one object. In fact, we handle its collections of value, large amount of collection of values. So whether it's map or hash or sets, linked lists, arrays. So would it be better to have a way to actually, anytime that we run a function, we get the elements of that particular collection, the first element, we run the function again, we get the element to the second position, we run that again, the third position, and so on and so forth until the end. Okay, because actually accessing data is a task in itself. Because when you do that in an imperative way, you're going to see how you need to know how to access data. All right. So on that topic, okay, what does it mean? This is, well, because first we look at how can we now access our data in an imperative way. Okay, so by using is the for loop, where here you describe is that yes, first is the initialization, so this for command or this loops, I know, take a look at this loop here from MDN, yes it is. Exactly, loops and iterations, please give me that in English, loops and iterations. One of the things is the control flow and error handling. That's interesting. Control flow and error handling, as it is. Switch a statement, control flow, break a statement. So all of our control flow is actually through is not only block statements, okay, but also is with conditional statements like if or switch. Okay, it can also follow is the best practice like this. Okay. Another thing is the falsy values. But this is the control flows, all right, as well as switch. You can also have defined this for specific use cases. So for example, like this. Okay, this is now control flows. Hey, I want you to now let the JavaScript pass through this particular flow, if it is, and that kind of thing. And now you can now is handle this errors. Okay, exception handling statement. So you have throw. This is control floats and error handling. Hey, throw this. So you're gonna throw an exception. And the other is a try and catch. So remember this particular topic here, okay, with the control flow and error handling on the try and catch statement, okay. Exactly, the catch block. All right. Something just to recap about what we're gonna do here, especially with the try and catch block thing here, right? Try nesting try catch statement. If an inner try block does not have corresponding catch block, it must contain a finally block, and the enclosing try catch statement block is checked for an undecline. For more information about C nested try and catch here, as you can see here, hey, I want you to now try this. If it's not, finalize this. And if there any error, this is nested try blocks. Or for example here, I want you to try this particular block, and then let's go to try this thing, and if you try an error, okay, move on here. And then finally, well, move on here. You say yes, you already got the data that you need to. And now let's rethrow an error. So it say, hey, I'm going to evaluate this. There is an error. It say, hey, inner error, okay. And then you have throw here, because you're now throwing is another error, which will be catch by finalize this, will be catch by the other error. So returning from a finally block here. So this is how you can do this flow control. All right. And again, this is quite not readable, as you might guess, especially because the more try and catch block statement that you have, the less readable it'll be. You know, again, the people now on the ECMAScript designers are actually working in improving that. All right. For example, like this, for await, okay. So with any generator and that kind of thing, hey, I want you to now run this, and then run the other, and so on and so forth, right? Another thing is that you say, hey, I want you to now, well, run all of this. The other is that you say, hey, instead of, you can say, hey, I want you to return is a new promise, or a promise dot resolve, okay, with 33 value, and a promise dot reject with 40 with throw error here, or in this case it's not a throw. I want this to now create a new error here, and say, hey, I want now you to make this as oops. Okay, so when we run this, exactly. And the funny thing is that that's interesting, but we will want to know is what happened with that rejected promise, right? Rejected. I think it's resolved and rejected. Exactly, with rejected promise here. As it is. Exactly, promise resolve and promise reject. Promise with resolver. Calling with resolvers on a non-promise constructor. Okay. But as you can see here, we are not able to actually read what's happening here, and that's quite interesting, because if we change now the order of execution here, it actually instead throw is an error. Oops. But that's what it is. So we are not able here is to actually handle rejections. That's something interesting here. It can be an iterable, an async iterable of sync iterables. Exactly. Of sync iterable. But the question remains that what will happen if you want to now handle those async functions, you know? And that's exactly what we'll take a look at now at the iterators, and how we actually have to do that with the for loops. Okay, as a way to say, hey, this is the for loop, this is part of the looping. This is part of the looping, or loops and iterations, right? So loops and iteration as a way to first looking at the the control flows and error handlings. Okay, and then when you're familiar with the block statement, how you can control flow with the if statement, okay, and by control flow, it's like you say, hey, let me now save this. Let me now, for some reason, instead of you evaluating that line of code, hold that execution or hold that reference until I tell you to do so, or until I want to invoke that function again and provide that. So again, here we're now looking is at the loops and iteration, how you can do that with 4 statements. Okay, you have the initialization, condition, and after through, and then you have to now explicitly tell how you can have access to each one of those elements. All right, which is so far so good, no problem at all. Okay, but uh, inside the but we got is this: a for statement, a for loop repeats until a specified condition evaluates to false. Right? No problem. So you have initialization, condition, and after through. As it is. So far, so good. No problem. We know how that works. Okay? And all of the serious steps that it's going to do. So when it comes now to do other types of loops and iteration, okay, so for example, like do while, we actually never use this. Okay, most of the time we use is the while. Okay, it'll make more sense. I would like to see statement repeats until a specific condition evaluates to false. The while statement is always executed one before the condition is checked. To execute multiple statements, use a block statement to group of those statements. If condition is true, the statement execute again. Exactly. At the end of every execution, the condition is checked. When the condition is false, execution stops and control passes to the statement following. And control passes to the statement following do while. So here we are now looking at this. So loops with the for or do or while, which is most likely used here. While statement. Hey, while this condition is, I want you to now evaluate this statement inside of a block until that is done, until that condition is no longer available. Okay, and then pass control to whatever is on the after while. So avoid infinite loop. Make sure the condition is in a loop, execute before eventually becomes false. Otherwise, loop will never terminate. The statement in the following loops execute forever because the condition never becomes false. And you got label statement. This is something that we barely use that, but this is as a way to say, hey, I want you to now to go to another part of that statement. Something that you can use, but for go to programming, you didn't want to do that. That's a definitely wrong place to do, and no, it's actually not solving our problems. It's not solving a problem at all. Not at all. We got the break statement. Okay, when you say, hey, now that I want you to evaluate this, you can use this in while, do, for, or switch. Okay, hey, once you reach to certain condition, break from that. For example, when we find the first elements in the collection, get out of it. We don't need to actually continue to evaluate. Useful for find elements. Find first. uh, and then you got the continue. Again, this is now loops and iteration. Okay, and when continuing is used with a label, it terminates the current iteration of the innermost enclosing. Okay, so what is the difference between break and continue? When you use a break without a label, it terminates the innermost enclosing while do for on switch immediately and transfer control to the following statement. And the other is continue, can be used to restore a while, do while, for, or label. It's like skip this condition. So far so good, right? And the for in statement, okay, which is now a new particular way of how we can loop through our code, especially on objects or enumerable properties. For in statement looks as follows, as a way to iterate in an object, and then we got the for of. Okay, statement created. For of statement creates a loop iterating over iterables, and iterables is those that follow the iterable protocol, which is now something that we're gonna see here. So the iterable here, okay, is those that follow is a particular protocol, and the protocol is and the protocol is, because it's a lot of, I'm gonna put it here as the next, and the protocol is that those object that has a wrapper, that is a collection, but has a wrapper with the next property. So anytime when you want is to access the proper elements, you hit the next function to get the current elements, and then hit the next function to get the next element, and so on and so forth, and that kind of thing, right? So as long as they have that interface implementation or that protocol implemented, okay, as long as they have that implementation, the iterator protocol, okay, as long as they have is the next element as well as done and the value, which are optional, okay, as long as they have that shape, okay, now they are is an iterable objects. So for example, arrays, maps, and sets, and arguments, objects, and so on are iterable objects. So they have now this ability in which we can control the flow of how are we getting access to this element. That's interesting. That's very, very, very interesting. Useful, especially when you want to now have access to collection of values such as array or set or maps. And when you say, I want you to now evaluate these particular expressions, I want you to do this for me, I want you to pass this high order function or this callback so you can evaluate that. That's quite interesting. For example, here, for of, but as long as they are iterable, now things makes a lot of sense. As long as they are iterable. Okay. So now that we know that, okay. What the? Okay. Okay. So now that we know that, let's get into the iterators approach. To the generators, exactly.
Excellent, there it is.
Okay.
Now we move on to, I said, once we rethink about data as a flow of data.
Exactly. So the value proposition of this, because after all this is generators, so value proposition, think of data as flow of data.
A string, we'll see something about data as flows, where we can pick off an element one by one, one by one, one by one. We can rethink how we produce those flows.
Think of that flow. Think of data as a flow of data. Okay. A stream. Where we can pick one by one.
JavaScript now lets us produce those flows using a function to set what individual element will be returned next.
When we start thinking of our data as flow, where we can pick of an element one by one, we can rethink how we produce those flows. Exactly. So think of data as flow of data string, where we can pick one by one. Okay, from a collection. So in the case of generator here, so valuable, think of data as flow of data string, where we can pick on one by one in a collection. In JavaScript, the iterator follows a protocol that is an object that wraps, that is an object wrapping collections of data with a next property, with a next, put it this way, with a next, exactly, with a next, like this, exactly, with a next, with a next value, and the other is done, which is an optional. Value and done, which both are optionals. It follows a protocol. When anytime we want an object in a collection, we can call the next methods. So far so good, no problem. So far so that definitely good. Okay, good. So now that we think, okay, now that we can think our now that we can think data as flow of data, where we can get elements one by one, we need to think about how to produce those flows of data. And that's interesting. So now that we can now that we can think our data, now that we can think our data as a flow of data, we need to think about how to produce those flows of data. Exactly. We need to now that we can think of data as a flow of data streamed. Exactly. As a flows of data. Now we need to know how we can produce those flows of data.
Fortunately, before we get to that, I've got to go back to something which honestly is a little bit annoying. We do need to understand it for us to use the built-in functions that produce flows, because they don't call a function directly, return next element. They instead have an object with a function on it, a method, next, that when called will give us the next element.
Exactly. So before that, we need to look at this particular example, because at the end of the day, they actually work by wrapping a function into an object that contain next method to call the next element, which is something that we are quite familiar with.
I want to build that from scratch ourselves, a final reinforcement of this model, but also to ensure we understand that this is just a function that's in an object now. But it's no different to what we did before. This should feel hopefully very clean review, but it will get us back up to speed before we move on to creating these flows using functions rather than underlying arrays of data. We're going to create a flow where we call a function each time, get the next element. Here we're doing it with a static, pre-built collection of data. In a moment, we're going to do it by yielding intermediate returns, you can think of those, out each of our next elements. Collection of data.
Yielding out.
Flow of data. A string. We'll see something about data as flows.
Yeah, we are decoupling is the way of how we access the data into what we want to do with the data. Mm-hmm. Exactly, as a way to build this. So let's first build this from scratch, okay, which is something that I'm quite familiar with. All right, especially here by saying, hey, I want you to create now as an iterator. You know, let me in fact call the same name as they call it here, create flow. They call that create flow. Really? I don't think so.
Where we can bet what individual element will be returned next. The built-in functions that produce flows, because they don't...
Okay. Create flow. And that is, well, let me now do is this, create flow function. It will be the function that will receive is initially a collection, an array, okay? And then this will return is now, as a naive approach, index equal .0, where where here we're going to now return this. So we can do something like this. We can say is this will be is now. How can we do this? We can define a function. We can just say something like this. This is the object that we want to return. Okay, we want to return is this object where it contains is the next, which will be a function that now here we can is access to the array. All right. And then return, you can say, hey, let's going to define is this as the value, okay, and the array as the index, okay, increment that index, and lastly return is the value, okay. And not only when we do this, because this might be here, but it's like when we're going to return this, okay, when we call this next, we're going to return that, and we're going to return is now we're going to return is that.
Call a function direct from scratch for data. Yielding is a lot of control over what those next values can be, because now we're just running code to generate those next values. Very, very cool. But first, let's just be clear. JavaScript's built in.
Because here we can say is this next function as a way to, well, anytime you want to get access to that, I want to say, hey, this is the function create flow as it is. And then when we want to actually create our flow, we can say iterator, where we're going to create the flow function with the 4, 4, 5, 6 or 6, okay. And anytime we call is the iterator next function, we're gonna get is the value from that. So let's go to the console. To the console. Here we are. All right, to the console. Here we are creating is this objects, okay, that when we are now invoking is the next function, because it's creating is a closure inside of that. This will be quite interesting, because to me this is quite challenging. So anytime you return is a function inside of even a nested object, it actually creates is a closure from that. That's to me quite interesting. So for example here, since we're returning is an object, but one of the property is a function, that property can have access to the outer scope. That's to me quite interesting. That's one of the finicky thing about JavaScript, you know. Hey, we got a 4. If we call the iterator.next, we got nowadays the 5, and so on. So now we have this stream of data, this flow of data that when we run a function can have access to. Now it is time to look at how can we produce these flows of data. And which the value will be is 4.
Return next elements, iterators they're called, are actually objects with a next method that when called return our next element from the stream or flow. So we don't call return next element, instead we call the method on it. So return next element is now an object, not a function, but it wraps a function. So we just call the function inside. But let's build it out ourselves. Let's restructure slightly to make sure we're truly clear on what this is doing. All right, but this should be fairly solid for us, as we just did this already. Find all that surrounding, let's do them in, until we've called return next. We know that the next call, again, not element is going to be declare element. When that function gets called, return next element dot next parens runs that function, it's going to have access to that backpack of data. It's the only way it gets access to data. By the way, to be really clear, we can't go return next element dot next dot array or return. Okay. We've just finished return next element is the return value of create flow, which was that object with next on it. And so what's our net? We come back out to global execution context, where upd our next global line of code.
Okay, so this is the diagram here. Okay. So here is the diagram of evaluating function create flow, okay, and then create, and then function, exactly, define function create flow, and then define iterator comes and assign it is value to, and assign it is value. That's one of the fucked up things of Javascript. It's like it also not only when you return a function, but even it's when you return a function inside of a property. Okay, or in other words, is that when you return a property, when you return a function as a property of an object, after all you're returning is a function. Okay, define iterator counts and assign it its value to. Define iterator counts and assign it its value to. Yep. Define iterator counts and assign it its value, from the result of create flow, which is this.
Is what? Works. Cool. Where do I look for return next element, the object?
In the global context.
Global memory, yep. And what do I look for on it?
Next method.
The next property, I'd say. You're right, yeah. And I hope it's a method, because it's got parens on the end. Is it? It is. Excellent. But it is not, JavaScript doesn't know it's a method, so to speak, at this point. You could try putting parens on the end of anything. But yeah, it is indeed a function, a method. So we create for it an execution context. We're not going to do both of these, we're just going to do the first one. Into it we go, and let's get this spot on. So Sean, first line of code inside the next method.
Element is declared.
Okay, element is declared. Excellent, exactly. Element is declared. So element is going to be, and remember, we're hoping this function is going to return out 4. That's what we're hoping. Element is going to be array position I. We do not know what these two little ones are here. Where do we look first, Sean, for array and I?
You look into the function next itself.
Yeah, exactly, the execution context, the local memory. Well done, yeah. Do we find it? No. I mean, hopefully we wouldn't, right? Because we want these to be persistent between function calls. And if it were looking here and finding it, then that would be a brand new data each time we call the function. So we wouldn't be persisting our data at all. Instead, we look next out to the next function's backpack of persistent data, where, Sean, what do we find?
We find array and I.
Array's value is?
4.
Array's value?
Oh, I'm sorry, 4, 5, 6.
And i's value is?
0.
Perfect. And we switch them in here. We put them in here. Let's do them in, which gives us in element what value, Sean? 4. But now we have another line. What's the next line in our return next element dot next method?
Add 1 to I.
Add 1 to I, increment I from 0 to 1. 4. First, it is not Java context. And remember, we're hoping this function is going to return out. Do we look first, Sean, for array and I?
So here we are going to evaluate the iterator next. Iterator next. Okay. Is this one? Okay, so here we're going to evaluate the iterator.next. So here we're going to evaluate iterator.next. First, we create a new brand execution context, okay, in which we are hoping to find, on the array, on the first position on the array, the value 4. But because we don't have that, okay, all right. So yeah, but because we don't have that, okay, and since we create is a closure, we can have access to that.
Six element dot next again, this time to give us these return next element, next element. Now we're going to get those elements out, not from a collection, but instead from a function as kind of intermediate steps in that function's execution. Really interesting. Kind of this fusion, always, increasing fusion of data with functionality. Now we're producing flows of data, not from a collection of data, but instead from a function where we evaluate statements and pull out the evaluated result as our intermediate, as our elements one by one. It's going to be very, very interesting how this works. How this code works is going to absolutely undo everything you thought about how JavaScript's execution model works. Not undo, it's consistent with it, but it's going to add a behavior that you never thought would be allowed. That I never thought would be allowed. It's not crazy, but it is a behavior that we never thought would be allowed. Okay, and it uses this new style of function, the star function, known as a generator function, to produce our flows of data. We're going to call that create flow. It's going to return out a special generator object into return next element. We're going to call that create flow. It's going to return out a special generator object into return next element.
Where we can have access to that.
With a next property on it, but when that next is called, oh, you wait for it, it's going to take us back in to continue our execution of our create flow function. It's then going to return out our result, and that's going to be our first element out. We've got to walk through this line by line and really get this precise. I'm hoping my board is wide enough for this because it's a fascinating new way. And again, not inconsistent with our model of JavaScript execution. It just allows us, because we're already very used to attaching to function definitions persistent state. We're just going to attach persistent state and a tracker of where we are in a function's execution. We'll see this in a second. Now,
Okay. So the value proposition here of the generators, exactly, generator function with dynamic data, now we can, because we can have, is a function.
We're just going to attach persistent state and a tracker of where we are in a function's
Exactly. We can have persist, so we can persist the state, exactly. We can persist the state of our data here. Okay. We can persist this state okay. We can persist the state of our data, okay? Exactly. We can persist the state of our data and have control about.
To attaching to function definitions persistent state. We're just going to attach persistent state and a tracker of where we are in a function's execution.
We can persist the state of our data and track where we are in the thread of execution. God damn it. That's interesting.
We'll see this in a second. Josh, line 1, what are we doing?
Declaring a generator function and create flow.
Yep, good. Declaring a special type of function. It's a magic new type of function JavaScript gives us called a generator function, create.
Which allows us to now produce flows of data for that.
We'll start. Okay, next line. I'm going to ask Brian, because I've asked him the same question as well, multiple times. I'm going to flip it up. I have an idea in my head about what question to ask each person. It's very interesting. Very interesting. Rick, what's the next line of code say to do?
You define a constant, return next element.
Yep.
Undefined right now.
Yeah, good. Excellent. Return next element, which is going to be the output of running. It's going to be the output of this call to create flow. What could the output of this be? Well, presumably, we're going to create an execution context. Probably, but no. For now, not in any meaningful sense to us. So we're in global. I'm not sure if I need to keep track.
So let's take a look at the Generators, my friends. Do we have that here? I think it'll be on the advanced. Regular expression, key collection, keys promise, iterators and generators. And this is on the basics and on the guide. Okay, oh my god. Exactly, iterators. Okay, and is that. So specifically an iterator is an object which implements the iterator protocol by having a next method that returns an object with two properties. The value I'm done. This is when we talk about iterators. This is a special object that is wrapped around those objects that follow the iterator protocol that exposes the next method where you can have as a result the value and it is done. Okay? This is done, this is true if the sequence has already been consumed, if value is present alongside for that. Alright. Yeah, we are quite familiar with this, and you're going to return is the range iterator for that as a way to implement your own iterator. And then you're going to return is the iterator count, because this is something that you must update it. That's right. Iteration count. Reset. Using the iterator then looks like this. So while of course, exactly, you're gonna call now these functions over and over and over and over as a way to get all of this data for that. Exactly. And then generators functions. While custom iterators are useful tools, their creation requires careful programming due to the need to explicitly maintain their internal state. Generator functions provide a powerful alternative. They allow you to define an iterative algorithm by writing a single function whose execution is not continuous. Exactly. You can define as an algorithm a series of steps whose execution is not continuously. Okay. Generator functions are written using the functions asterisk syntax. When called, generator functions do not initially execute their code. Hold. Okay. Instead, they return a special type of iterator called generator. When a value is consumed by calling the generator.next method, the generator function executed encounters the yield keywords. So anytime it encounters the yield keyword, it's like, hey, I'm going to return is this. Okay, and if I hit next, I'm gonna call this next. And when that is done, okay, you're gonna pass that callback to the call stack as a way to resume the normal execution of that async operation. Which means that now you have is the data available there, so you can, god damn it, so you can now continue to evaluate that. Oh, this is pornographic. Oh my freaking touch goes that. Oh man, this kind of people actually are consuming some sort of drugs, bro. Oh man, it's like, oh shit, nigga. These people must consume some sort of hallucinant something. I don't know. It's like, where all of this influence, where all of this thing come from, bro? You know, yeah, through mathematics, through the geometry, but all of this is like, you dedicate a lot of time to think about that. But a lot of time. but a huge amount of time. Mm-hmm. Exactly, but it's because now is able to now keep up the internal state of that. The function can be called as many times as desired and return a new generator each time. But again, this function, because it's going to allow us to the ability to control how we produce these flows of data. And because when you create your flows of data, especially when you want to access or to keep track is at which line of code you are and which state you have, maintaining this internal state is complicated or requires careful programming. But careful programming. So generator functions is a way for us to say, well, I'm going to now delegate, I'm going to now write this algorithm, and when you find yield, now not stop the execution. Okay, when the value, so when called, generator function do not initially execute their code. Instead, they return a special type of iterator called generator. So when a value is consumed, is by calling the generator's next method, the generator function executes until it encounters yield keyword. The function can be called as many times as it is desired, but the idea here is that they allow you to define an iterative algorithm by writing a single function whose execution is not continuous. So by defining an iterative algorithm here, alright, so by defining an iterative algorithm here, by writing a single function whose execution is not continuous. So you're going to now define is the algorithm in an iterative, or you're going to define an iterative algorithm whose execution is not continuous. To put it simple, you're going to define a series step to take you're going to define a series of steps in an iterative you're going to define a series of steps in an iterative, synonymous of iterative, bro. In a repetitive path, okay, in a repetitive, in an iterative, in a repetitive, okay, you're going to define an iterative algorithm like this, okay. So you're going to define a series of steps repeated, okay, by writing a function that will be run that will not be run continuously. So by running by defining these functions that you will be by defining this series of steps that you want to do repetitive, okay. So for example, by defining this series of instructions that you want to do repetitive, okay, for a goal, let's say you want to define a series of steps to your Monday, Wednesday, and Friday to perform a upper chest, okay. So by defining this function, this program, okay, on Monday, Wednesday, and Fridays, what you're gonna work is full body, okay. You're going to define out this particular program each one of those days. You know, each one of those days, this is what you're gonna do. Of course, with a particular goal. in this case, you're gonna do until it find the last element. So in other words, these generator functions, what allows us to define is it's a functions, or it's a series of steps that we're going to run on, that we're going to run in repeated algorithm, in a collection of algorithms, okay, until we reach the end. If you want to translate that into real life, you want to do this. Pretty much when you hit the gym, all right, you want to do this program, okay, Monday, Wednesday, and Friday. Let's say full body. Let's say full body. You want to do this, and when the time is right, you're gonna do that, and you're gonna do that, and you're gonna do that. 1 week, 2, 3, 4 weeks, until you get an outcome that you want, right? That's quite fucked up and powerful. Okay. An object is an iterable if it is defined an iteration behavior, such as what values are looped over in the for of construct. But it returns a generator. It returns a generator, a special type of iterator. It returns a special type of iterator, a generator. It returns a special type of iterator, which is a generator. Okay. Move on. Let's keep. Yep.
Track of the. Nah, it doesn't want to track of the full stack desperately. We need as much space as possible. So, okay. So we're hoping the output of return next element is an object with a method on it called next. That when I call that, it's going to give me my first element in my flow of data. What do you think that's going to be, Ben? 4. You hope it's going to be 4. Okay. Next time it's going to be 5. That's going to be 6. How are we going to get that? That's the interesting question. So create flow does not go Ben. Object return called next. But when I call that, it's going to give me my first element in my full. So we're hoping the output of return next element is an object with a method on it called next. But when I call that, it's going to give me my first element in my flow. I'm calling create flow. Now, then, we're hoping that when I call, so we're hoping the output of return next element is an object with a method on it called next. But when I call that, it's going to give me my first element in my flow of data. What do you think that's going to be, Ben? 4. You hope it's going to be 4. Okay? Next time it's going to be 5. That's going to be 6. How are we going to get that? That's the interesting question. So create flow does not go inside create flow's execution context. Instead, it returns out a special generator object with a next function on it that when called is going to do something fascinating. There it is with next. That's the function. Okay, that's been stored in return next element. So now return next element has a next method on it because it was the output of running create flow. We've now finished this call to create flow. So now our next line of code says to do what? It's got to be only one person. Abdi?
Oh yeah, we're just declaring it in memory again.
Yeah. You're getting too complacent. complacent about your report responsibility. We're declaring what? We're declaring the element 1. Excellent. Thank you. And we're now going to call the method on this return next element object, the next method. And what's it going to do? Here's what it's going to do, people. You never thought it would happen. It is going to execute, or begin execution. It's going to open the execution context of create flow. This function on the object that got returned out of create flow.
Yeah, thing.
Has an intimate bond to where it was born at create flow, that when we call the next is going to initiate calling create flow, the function from which it was born. It's going to start calling it. Now, I'm going to talk to you in a moment what that literally means. What is calling a function? What is executing code? And how do you keep track of that? It's not as profound and as bizarre and kind of against the rules of JavaScript as you might think. Okay, so when it does that, it's going into the execution context to create flow. That is what it is. So what's the first thing it does? Actually, it's a pretty boring function. There's no memory allocation happening. What's the first line it hits, Michelle?
Yield 4.
Yield 4. Okay, yield is a super powerful keyword that's like return that exits out of the function, but it's suspending the execution context. It's not ending it. What that means, I'm going to talk about in a second.
It's pause and
Again,
resume
it's
the
not like
generator
it's
file.
sitting there on the call stack, sort of there. It does something else. I want to make sure we get that clear, what it actually means to suspend an execution context. But this is a return statement, essentially. We are going to grab that 4, and we're going to return it, yield it, out as the output of our return next element .next call, which stimulated create flow to call. It hit the yield statement inside. That 4 is going to be not our output of create flow. That was create flow's never going to give an output again directly. It's only that return next element .next took us in here, and the yielded result is then the output of that statement we just called return next element .next. Actually, I want to do a dotted kind of line here to show that create flow's kicked off. So this is an output of return next element .next, which is 4, and that's going to be assigned where, Blessing?
So element 1.
To element 1. Excellent, there it is in element 1. Beautiful. Great to see. I'll say this, we've ended up here with our flow of data to the first element for it. Very nice. Right now we're going to see that it doesn't feel that much different, like we've got 4, 5, 6. But in a moment we're going to see we can dynamically control what our flow of data comprises. This is just code now. We can set what our data flow comprises. Alright, so next line of code, Alec. We're back out to global. Oh, I should say, sorry. We've paused. I don't like the term pause, but we suspended, we put on hold the execution context here. What that actually means, I might as well say now, what that actually means is, no, I'm going to say it on the next slide. So for now, okay, Alec, we come back out to our global execution context.
Okay. Yeah, that'll be all for this video. Okay. Take care. Bye bye.